Alright, now that we've spent some time working on how to find the equations of parabolas, it's now time to take and apply these ideas to a problem. So, we're going to be looking at problem 67 from section 9.2. We're going to apply this idea of parabolas to the following problem. So we're told the cables of a suspension bridge are in the shape of a parabola. The towers supporting the cable are 600 feet apart and 80 feet high. If the cables touch the road surface midway between the towers, what is the height of the cables at a point 150 feet from the center of the bridge? So let's just break this down a little bit here. It's important that we notice that the problem tells us that the cables are in the shape of a parabola. Bingo. That tells us that we're going to be able to apply what we've been thinking about so far in this chapter 9. We also know that the cables, from the supporting bridges are 600 feet apart, and that at the midway point, these cables are going to touch the ground. Or I shouldn't say ground, but are going to touch the center of the bridge. Okay. And we know that our supporting towers are 80 feet high. So with any word problem, it's valuable to notice those key things, and then not just only notice them, but then take the words and create a picture. Here's a diagram of this problem. You notice here is a support tower, and this support tower is 300 feet from the center. I know that because they told me that my bridge was 600 feet wide and that the cables touched at the midway point, causing me to know that it's 300 feet. Okay, now, since I know that this is basically the vertex of my parabola, I'm just going to call this point 0, 0. By doing that, I now have a vertex. Not only do I have a vertex, but I'm going to be able to figure out what my base equation is. Because now I have this parabola opening upwards. Okay? So my base equation is going to be x squared equals ay. So let's write that down. Alright, this is kind of similar to the last problem we did, because now I have a point on my parabola. This point happens to be 300 with a y value of 80. So I'm going to go to my base equation, I'm going to solve for a. In order to solve for a, I'll substitute in 300 for x, and I will substitute in 80 for y. So in order to find a, I will have 300 squared over 80 equals a, which happens to equal 1,125. That's pretty helpful, because now I can write the equation of my parabola. Let me write that 2 a little bit better. Alright, so I've got my equation of my parabola. Now, the question of this problem really was to determine the height of the cable if I'm 150 feet from the center of the bridge. Fortunately, that tells me my x value. So really, I'm trying to figure out right here. See, I've got my x value, but I want to know what the y value is, the height. So, by going to my equation of the parabola, I can substitute in my x and conveniently solve for y. So let's do that. In for x goes my y value. In for x goes my x value of 150 squared equals 1,125y. So if I take 150 squared and divide it by 1,125, I'll be able to find y, which, if you do that with your calculator, will come out to a value of 20. Therefore, my bridge, the height of the cable at 150 feet from my midpoint on the bridge, will be 20 feet. The height is 20 feet at 150 feet from the middle. So, on Friday in class, we're going to work on applying these ideas of parabolas to solving problems relating to bridges, to how to figure out the height of different arches, spotlights, and also solar heaters. So really, knowing how to find the equation of my parabola from just a point is really going to be a helpful and important tool for solving real-world applications involving parabolas. See you Friday!